We want to solve the equation sine squared t equals 2 cosine t for all solutions on the interval from 0 to 2 pi. So if we have the equation sine squared t equals 2 cosine t, we want to begin by writing this in terms of one trig function. So we'll perform a substitution for sine squared t using the identity sine squared theta plus cosine squared theta equals 1. Notice if we solve this for sine squared theta, we'd have sine squared theta equals 1 minus cosine squared theta, which means, in our case, we can substitute 1 minus cosine squared t for sine squared t. So we'd have 1 minus cosine squared t equals 2 cosine t. Notice how this resembles a quadratic equation because of the cosine squared t. So we'll set this equal to 0 and see if it factors. We want this squared term to be positive, so in this case, we'll add cosine squared t to both sides, as well as subtract 1 from both sides. So that would give us the equation 0 equals positive cosine squared t. We still have plus 2 cosine t, and then we'd have minus 1. Unfortunately, there are no factors of negative 1 that add to positive 2, so this does not factor, so we'll have to apply the quadratic formula in order to solve this for t. Again, the given equation here resembles the quadratic equation where we would have 0 equals x squared plus 2x minus 1. Notice in both cases, a is equal to positive 1, b is equal to positive 2, and c is equal to negative 1. But now when applying the quadratic formula, instead of having x equals, we'll have cosine t equals. So we'd have cosine t equals negative b, that'd be negative 2, plus or minus the square root of b squared, that would be 2 squared, minus 4 times a, which is 1, times c, which is negative 1, all divided by 2 times a, or 2 times 1. Now let's go ahead and simplify this. We have negative 2 plus or minus the square root of, this would be 4 plus 4, or 8, all divided by positive 2. Well, the square root of 8 is equal to the square root of 2 times 2 times 2. And since the square root of 4 is equal to 2, this simplifies to 2 square root 2. So we can write this as cosine t equals negative 2 plus or minus 2 square root 2 divided by 2. Notice how this will simplify, but we cannot simplify across addition or subtraction. So let's write this as two separate fractions to simplify correctly. We cannot just simplify these 2's here. We would have negative 2 divided by 2 plus or minus 2 square root 2 divided by 2. So cosine t is equal to negative 1 plus or minus square root 2. Now we're trying to solve this for t, not cosine t, and having a cosine function value of negative 1 plus or minus square root 2 does not result in a nice reference angle. We'll have to get a decimal approximation for these two cosine function values. So negative 1 plus square root 2 is approximately 0.4142. Let's go ahead and write that down. And then for the second value, we would have negative 1 minus square root 2. Remember, the cosine function can only return a value from negative 1 to positive 1. It'll never have a value of negative 2.4142, and therefore this will not give us an angle that solves our equation. But let's write this down anyway. We would have cosine t equals negative 2.4142, which can never be true. So now we'll focus on determining the angles over this interval where cosine t is approximately 0.4142. So to solve this for t, we can take arc cosine or inverse cosine on both sides of the equation. So on the left we would have t, and on the right we'll have to use the calculator to get a decimal approximation. Notice how we do want the angle in radians, so we do have to make sure our calculator is in radian mode. So let's press the mode key. Notice how we are in radian mode, so we'll go back to the home screen. We'll press second cosine for inverse cosine or arc cosine, and then 0.4142, close parenthesis, and enter. So one solution is approximately 1.1437 radians. But there will be another solution. Let's begin by sketching this angle in standard position. The initial side would be here. The terminal side might be approximately here. Or again, this would be approximately 1.1437 radians. But remember, the cosine function value, since it's equal to x divided by r, is also positive in the fourth quadrant here, where the x coordinates are also positive. Which means we can find our second solution by sketching a reference angle of approximately 1.1437 radians in the fourth quadrant. So the angle would look something like this, where again this reference angle here is approximately 1.1437 radians. So the measure of this angle that terminates here over this interval from 0 to 2 pi would be this angle, which should be 2 pi radians minus the reference angle of 1.1437 radians. So we'll call this t sub 1 for our first solution, and t sub 2 would be approximately 2 pi minus 1.1437 radians. So t sub 2 would be approximately, going back to the calculator, 2 pi minus 1.1437 radians, which is approximately 5.1395 radians. So again, we have two solutions. The first solution is 1.1437 radians, and our second solution is approximately 5.1395 radians over the interval from 0 to 2 pi. I hope you found this helpful.